Okay, good evening everyone. Welcome back. I'm here to record the second screencast for Module 1 on intelligence. Screencast, we're going to go over the following learning outcomes. We'll explain intelligence quotient scores in terms of their characteristics. We'll describe the scientific evidence that environment and heredity influence IQ, and we'll define the concept of reaction range, and we'll evaluate socioeconomic disadvantages as explanations for differences in IQ. So we covered the intelligence quotient score in the last screencast, and there we described how it is a formal measurement of intelligence that is achieved through standardization. So the formalization of this score as a metric for intelligence is achieved through standardization, and that's accomplished by administering the test to a representative sample. So from the population, a representative sample is selected, and the scores of those individuals establish the norms. So these are normative scores against which individual scores are going to be compared. And so the norms are the scores of those in the representative sample, and those scores establish the norms or the standard of comparison to which all individuals' scores will be compared. And so here we see that IQ scores, when plotted, they form what's called a bell curve or a normal distribution that has important characteristics. So the IQ score mean is 100. So is the median. So it's the same point along this distribution. And so the norm of the medium of a normal distribution, of which the IQ scores form a normal distribution, is 100. So it's characteristic. It's a characteristic distribution for IQ scores. So 50% of the scores fall above and below the median or the mean. 68% of scores lie between 85 and 115 points, and 95% of the scores lie between 70 points and 130. Now, the outliers beyond these points represent only a small portion of the population. So only a very small portion of the population is represented below 2 standard deviations from the mean, as well as above 2 standard deviation from the mean. So a small percentage of people have a small IQ below 70 points, or a very high IQ above 130 points. So scores below 70 are indicative of the presence of a developmental or learning disability, and scores above 130 are indicative of giftedness. So those are important characteristics, and a standard deviation is 15 points. 15 points represents 1 standard deviation from the mean. And so someone with an IQ of 115 is 1 standard deviation above the mean, and a person with an 85 IQ score is 1 standard deviation below the mean. Hence, here -1, this represents 1 standard deviation below the mean, and +1 or 1 represents 1 standard deviation above the mean. Okay, so now we're at the learning outcome 4, which is describe the scientific evidence that environment and heredity influence IQ. So we'll start with the effects of the environment. So we'll focus specifically on health. And so environmental factors play a role in determining IQ. Studies show that proper childhood nutrition appears critical for cognitive development, and malnutrition can lower IQ. So for example, studies have found that iodine deficiency causes a fall an average of 12 IQ points. So it is expected that average IQ in third world countries will increase dramatically if the deficiencies of iodine and other micronutrients are eradicated. Okay, so now we're going to look at the influence of heredity on intelligence. Studies have examined similarities and differences in IQ within families, particularly by looking at adopted children and twins. And family studies show that intelligence tends to run in families. Indeed, studies suggest that genetic factors underlie about 50% of the difference in intelligence among individuals. So this twin studies reinforce this pattern. Twin studies show a higher correlation between identical twins. So there's a higher correlation of IQ scores between identical twins than between fraternal twins. So identical twins, of course, are monozygotic, and fraternal twins are dizygotic, or so they're dizygotic, and monozygotic twins have a higher genetic resemblance, of course. So when this holds true, this higher concordance in monozygotic twins holds true even when they are reared apart in comparison to fraternal twins reared together. So when we look at monozygotic twins or identical twins reared apart, they have a higher concordance in their IQ scores than that of dizygotic twins reared together. So that's a comparison of a correlation coefficient of 0.78 in the monozygotic twins reared separately versus a correlation coefficient of 0.6 in the dizygotic twins raised together. And adoption studies also support this pattern. So studies show that adoptive siblings are no more similar in IQ than strangers. So the IQ correlation of adoptive siblings is close to 0.3, is quite low, and so their IQ correlation is no more similar than that of strangers. So our next topic is that of a reaction range. So in genetics, the reaction range describes how the phenotype or the expressed characteristics of an organism depends both on the organism's genetic characteristics, their genotype, and the environment. As it pertains to intelligence, reaction range refers to the limits set on IQ by heredity. So this concept focuses on the interaction between genotype and the environment in which the organism is raised. So the environment determines where IQ will lie within these limits. So the reaction range describes the upper and lower limit on IQ that is determined by heredity, and the environment determines where the IQ will lie within these limits. So you can see here that a child with a given IQ range will, his or her potential will be determined by the environment in which he or she is raised. So in a lower restricted environment, the genetic potential does not fully materialize or doesn't fully manifest itself. But if the child is raised in an enriched environment, then the genotype can fully express, or the child can fully express its potential and its intellectual abilities. And finally, we're going to evaluate socioeconomic disadvantages as explanations as explanations for differences in IQ. So many studies have examined the role of one's socioeconomic status on intelligence. So a socioeconomic status refers to an individual's place in society, and studies have examined whether children who are raised in environments or in families of lower socioeconomic status, whether it impacts or it affects their performance on intelligence tests. Now, socioeconomic status does impact an individual's experience, their access to educational and cultural experience, and the extent to which they have privilege within society to access those experiences, educational and cultural experiences. So it does impact the individual's experience since childhood and into adult life. Socioeconomic status as it pertains to children is often measured by family income and parental education. And what studies report is that socioeconomic lower children of lower socioeconomic families perform on average worse on intelligence tests than children from higher socioeconomic status backgrounds. Children from low socioeconomic status scored on average 6 IQ points lower at age 2 than children from higher socioeconomic status backgrounds. And by age 16, this difference had almost tripled. So overall, socioeconomic status has been shown to be associated with differences in performance on intelligence scores. However, these findings do not warrant causal interpretations between socioeconomic status and the development of intelligence. So it's important to realize that they are correlational and they do not allow or warrant a causal interpretation of the relationship between socioeconomic status and intelligence in children.